Hello, this is question 3 from paper 1 from the 2020 ordinary level Leaving Cert maths exam. Up the top right you'll find a playlist that has all my solutions to the questions in this paper, and below the video you'll find a link to an image of this question so you can try it in your own time before looking at my solution. We have here a complex numbers question. This is an Argon diagram. We have the real axis and the imaginary axis. And they give us some of these z's. They always use z in complex number questions. Instead of x equals 5 or something, we have z equals a complex number, 3 minus 4i. And the first question asks us to write z3 in a more normal fashion, a plus bi. So that's like this or like this. So this is 2, that's a bit unclear, 2i multiplied by z2. So how do we do that? Well, let's write it again. Z3 is equal to 2i. Now instead of Z2, we know what Z2 is. It's right here. Z2 equals this. So instead of Z2, you can write minus 2 plus I. That's the same thing as this. Now we know where to go from here. We multiply them in. 2i multiplied by minus 2. Minus by a plus is a minus. 2 times 2 is 4. I times 1, I guess, is I. We get minus 4i. 2i times I. We get plus by a plus. 2 times a 1. I by I is I squared. I squared, we know what I squared is. I always like to leave it up here somewhere. I squared is minus 1. So let's write it again. Minus 4i plus 2 multiplied by minus 1. Plus 2 by minus 1 is minus 2. So that's minus 2 minus 4i. That's how they wanted us to write that. That's part A, part 1. For part A, part 2, they'd like us to plot all three of these. Let's replace this minus 2 minus 4i for now. Okay, my drawing is not the best. You should have a perfect drawing in the exam because axis-wise, I mean. Okay, so what do? We got the 3 on the real, here's 3 here, and we got minus 4 on the imaginary. 1, 2, 3, 4. Minus 4 here. And where did they meet? They meet right there. That is Z1. And we just continue on. Minus 2 plus 1 is here. That's Z2. And then we get minus 2 minus 4 is down here. That is Z3. Alright, they sometimes, just be warned, they sometimes ask you about the shapes here or the lengths here, anything like that. They didn't in this case, but it was a right angle triangle, which I find a little interesting. Right, what did they ask next? Part 3, they ask for the modulus of which one? Z1. The modulus of Z1. Now, some students remember how to do this, 3 minus 4i. They remember the formula for this. Another way to do it is, it's really the length from here to 0. That's what they're asking. So all we need to know is, I've drawn too many triangles now, that's unfortunate. And this triangle here would tell me a lot about the modulus. This length here is 3. This height here is 4, between 0 and minus 4. So let me draw that triangle again. 4 and 3. What we really want to know is just this length here. I won't bother doing it that way because I want to show the formula. Lots of students just remember the formula. It's this number squared plus this number squared. So that's minus 4 squared and the square root of it. But that's the same, except for the minus, as Pythagoras' theorem. 3 squared plus 4 squared is equal to this squared, or the square root of this is equal to this squared plus this squared. So this is equal to 9 plus 16, say square root again, which is equal to square root of 25, which is equal to 5. And that's also the length of that. That's the modulus. That's the modulus of Z1. Okay, that's part 3. Oh, one more part. Part B, they would like us to get... Okay, yes, let me clear off this here. I'll clear off here and I'll do it. As we know, the first part tends to be easier than the last part, so we do expect this to be a bit harder. Z4 has appeared and it's equal to 29 plus 3i. They would like us to write Z4 in the form of a plus bi, just like they asked for Z3. So how do we do that? It's not as hard as it seems. Lots of students got very confused by this. They just want Z4 on its own. Just like when you're solving for x, you want this number on its own. So this is not x, remember, this is multiply. Well, let's get rid of this Z1. It's multiplying, so we move it across, it becomes divide. So the Z4 never moved, the 29 plus 3i never moved. Remember, this is one number now. This is one number. Z1 is one number. Let's divide it across. So that's what Z4 is equal. And also remember, we know what Z1 is. Z1 is 3 minus 4i. So there's Z4. Z4 is equal to this. Lots of students didn't realize it was a division question. They didn't realize to change this into this. But now that we know it's a division question, how do we solve that? We want to get rid of this bottom row. And there's a nice trick we've learned how to do it. It's multiplying it by its conjugate. And we do this, well, first of all, why are we allowed to multiply by something? Well, it's the same thing divided by the same thing, like 4 divided by 4, or 19 divided by 19, or I divided by I. It doesn't mean anything. It's 1. Everything here is 1. It's something divided by itself. So I'm just multiplying it by 1. I'm allowed to do that whenever I want. But I use this specific number because I know when I multiply these bottom row, the i's will all disappear. That's why we do this. But more usually students just do it because they were told to do it. That's fine. Alright, top by top then. Let's go. Let's start here. 3 by 29 is 87. 3 by 3i is 9i. 4i by 29 is, let's see, it's 120. Take away 4, so 116i. And then 4i by 3i is plus 12i squared, which becomes minus 12. The bottom row becomes 9, 3 by 3. 3 by 4i is 12i, minus 4i by 3 is minus 12i. They cancel. Now, it's okay not to write them because you knew they were going to cancel. Minus 4i by plus 4i is minus 16i squared. I squared is minus 1, so it just changes it to a plus. Alright, let me take the next line. I should have started a little more over. Take the next line up here. We have 80, well, let's add these together. 87 minus 12 is 75. 9i plus 16 is 25i. And the bottom row is 9 plus 16 is 25. Let's see, 25 goes into both of them. So, well, yeah, let's try it like this first. 75 divided by 25 plus 25 divided by 25i. That goes in 3 times. This goes in 1 time. So it's 3 plus I is our final answer. That was for Z4. Z4 is equal to this. Did they want us to draw that in the picture as well? Let's see. No, it doesn't look like it. But they often do. They often ask us to draw that. Where would it be? 3i. It would be up here. And it would actually make a nice little square. Which, have a think why that is maybe. I don't know. I haven't thought about it. It might have an interesting solution. Alright, if you have any follow-up questions, or if you're unsure of anything, or there's any mistakes I made, let me know in the comments below, and I'll do my best to get back to you. Thanks for watching. Have a great day.